Hello and welcome to SW. My name is Eileen Fries.
And my name is Benjamin Hogg. I'm a project engineer here at SW.
We're here in the assembly hall today, so please excuse the noise. We're here to learn more about knuckles. Benjamin, maybe you could start by explaining what these workpieces are.
A knuckle, or steering knuckle, is built into every vehicle. They bind the car body with the wheel itself. The knuckle is mounted on the rear axle and the steering knuckle is mounted on the front axle. The main function of both parts is to hold the wheel bearing and to have the brake caliper fastened to them.
Die Hauptfunktion ist, wie gesagt, die Verbindung, die Aufnahme des Radlagers und die Befestigung der Bremssättel.
What are the different types of the two workpieces?
There are several different types. In principle, every manufacturer has their own style. There are many different variants. Obviously, you have to be able to look at how they're going to be used. A small city car is going to need a different knuckle than an SUV, for example.
I can see that you brought 3 options here. Maybe you can use these models to show us the differences and similarities.
Sure. Here, for example, is a steering knuckle that's been manufactured from cast iron. You can see that it's clearly heavy, very stable, and pretty massive. Then we have one that's made out of aluminum. It's lighter, but still just as stable. Here, we see a long-haul steering knuckle. You can see that it's clearly larger in comparison to the cast knuckle that we have. And then here we have a knuckle made from cast aluminum. Although the components are very different, they have certain elements that are the same or that can always be found in knuckles and steering knuckles. Here you see the main bore for the wheel bearing. Then inside, we have 2 more drilled bores on the wings. And we see them again here. There, the caliper has been fastened, and you can always find an ABS boring. This is where the ABS sensor will be built in.
Da ist der Bremszettel dran befestigt und es ist auch immer eine ABS-Bohrung vorgesehen. Hier wird der ABS-Sensor eingebaut.
It's really interesting to see these examples. Maybe we can discuss how these are manufactured on SW machines.
The first, most important question is, which machine is going to be the right machine? We have a very, very broad product portfolio. Some machines may be too small for these components. Therefore, it's essential to pick the right machine. We have 2 broad groups, one group for light machining and another for heavy machining.
Could you explain one and then the other? Maybe you could begin with the heavy machining group.
Sure. Heavy machining would in this case be the wheel carriers made of cast iron. Here we have a machine with ball screw motors in its axis for the feed rates and high feed forces. And we have large spindles with strong torque. These are the HSK 80, HSK 100 spindles, and the machine is distinguished by its high level of shock absorption. This means that we're going to have very low vibration machining, even during heavy machining. And then there's the light machining. The machines in this group are characterized by the linear motors in their axis. This is comparable to high-speed maglev monorail technology. These machines are equipped with HSK 63 spindles. These spindles have high rotational speeds with somewhat lower torque, which isn't really necessary in this case. What makes these machines special is how dynamic and how very, very precise they are.
You mentioned that the machines have to be very robust, which is of course fundamental to all our machines and part of our design principles. The monoblock is very helpful, especially in comparison to C-frames, which constantly have a lot of movement, especially when we have such heavy machining material.
Exactly, as well as these very dynamic forces or movements relevant for light machining.
Exactly, yes. Now, we've talked a little about how or what the 2 machine groups are. What is the clamping like?
There are different concepts. Very often, knuckles are only manufactured in one clamping setup. But of course, there is also the option of manufacturing in 2 clamping setups, for example. I'd like to show the viewers a few things. We have, for example, a cast iron knuckle. This workpiece has an OP10, OP20 solution with two setups on the fourth axis. We see a total of 6 components here. This machine is a BA732, which means that it has 3 spindles, and now we have 2 workpieces per spindle, which further increases efficiency because 2 components are machined per tool change. Then for the OP20, we have a 5-axis solution. We have 3 rotary tables, which means 5 axes per spindle. And again, 2 workpieces per spindle, which is a great advantage. With this, SW is distinguished by the fact that one machine can process both right and left steering knuckle. Every automobile needs a right and left component, frontal and rear. That means we can finish a complete set directly in one cycle, with no need for a second machine. Of course, we also have a solution with one clamping setup that would be used for this example. Here we have a frame fixture, so the workpiece is clamped directly on the frame. That allows for a high level of accessibility, while the workpiece has all the points supported in order to process the workpiece securely. In just one clamping setup, we have the advantage of a simple part handler that doesn't need another clamping. So clamping errors aren't an issue here, and even in spite of this, we have a machine with 2 work tables. Double work table machines can machine both left and right components, so we have a complete set.
Der Umspannfehler gibt es natürlich dann nicht. Und trotzdem, da wir ja Maschinen haben mit 2 Plätzen, 2-Platzmaschinen, können wir mit einer Maschine sowohl linke als auch rechte Bauteile herstellen und haben komplette Sätze.
Just now, you were talking about how we have solutions for clamping errors. Do these kinds of errors normally occur during loading? We've been talking about having 6 components clamped at once so that workpieces can always be replaced, loaded, and unloaded. SW is more than just a machine manufacturer. What other solutions do we offer for this?
Of course, we don't just offer the machine, fixture, tools, process, and turnkey project, but also automation solutions. We have many different concepts. We have standardized solutions for 1 or 2 machines like the top rob or floor rob, which are now available. We can also offer you a specialized solution. That means we can completely link 15 machines, or however many you need, and you can still link the full production line. For example, a brushing cell, a washing cell, or even a labeling cell. We would be happy to provide a complete system solution.
I think this is particularly important for these workpieces because you can see the selection and the diversity per workpiece are significant. It's simply a matter of finding the best solution for the customer. We are very flexible, and we have seen a lot over the years with our customers. So, if you're interested, we would love to take a look at your workpiece. Benjamin, I'd like to circle back to the topic of tools. What can we tell our customers about them?
When it comes to tools, we always try to tailor the tool to the workpiece as much as possible. This increases efficiency and output and reduces cycle time. Now, I would like to show a couple of examples. Here we have a step drill with 3 steps above it. It's still an example step, so you can actually map 3 processes. 3 steps, 1 tool. Now, here's a tool for cast iron. We have a reamer with 5 cutting edges so that this bearing bore is high quality and boasts a very precise and exact tolerance. Now, for our next example, we have a conical reamer. Here, you can see the connections for the lower control arm and so on. There are special solutions for these. Here, a combination approach was taken. A set gang milling cutter and, in the front, a step drill. With this combination tool, for example, the eye for the brake caliper can be machined directly on the upper and the undersides. And here is where the drilling is brought in. We have special tools for aluminum that, thanks to their PCD cutting edges, have high cutting speeds, which shortens the cycle time. What we see here is a tool with various stages, which enables us to mill circular grooves and diameters in one milling process. And last but not least, here we have an example of a pre-driller that is a combination. We have a PCD chamfering step and a cutting surface ready to sink at the back, and we have a pre-drill in front with high metal plates for drilling the hole in the steps on the component equally while the plank is still being plunged.
Und nicht zuletzt hier noch zum Beispiel ein Vollbohrer. Das ist jetzt eine Kombination. Wir haben hinten eine Schneidstufe aus PKD, um eine Stirnfläche fertig zu planen zu senken. Und haben vorne auch nochmal einen Vollbohrer so genannt mit Hartmetallplatten, mit dem die Bohrung zunächst aufgebaut wird und im Schritt darauf im gleichen Zuge aber die Planfläche noch angesenkt wird.
I think it's safe to say that it depends largely on the customer and their challenges. Not every component is going to need a special tool. There are also workpieces that can be machined with standard tools. Can you tell us a bit about the behind-the-scenes thought processes and development work for finding the best solution for our customers? Of course, it would also be interesting to know what we can deliver in terms of output. That's what the customers really want to know. They're thinking, oh, these people have said a lot, but as always, it comes down to numbers.
It really depends on what kind of workpiece is being machined and how complicated it is. However, I can use these components as examples. We have a solution here that processes 250,000 workpieces per year, which means 125,000 sets. Then here, the component is somewhat more elaborate when it comes to machining. The output here would be about 100,000 per year. And for this knuckle, we can reach up to 200,000 annually.
These are very compelling numbers. As always, we're enthusiastic. We're always working hard to improve over the years, especially for our customers. What are the other benefits we can share with our customers about these workpieces too?
I think what makes us really stand out is our wide portfolio of machines and solutions that we have to offer. So wide and varied, like the pallets of components of knuckles that we have here. We have the right machine and the corresponding concept. We have experts for fixtures and experts for tools. That means we can all work together to create a solution that will make sure you achieve what you want. And last but not least, we have our automation solutions, of course.
Nicht zuletzt haben wir natürlich unsere Automationslösungen noch.
We can't forget that.
Exactly. We have to complete the picture.
The automation solutions are important, of course, regardless if you already have one or are considering trying the option again. Just talk with us. Benjamin, thank you for the interview.
You're welcome.
Sehr gerne.
And I hope you can take something away from this. If you have a certain workpiece that's maybe already in production or something you're considering for the future, just get in contact with us. We would love to do a time study, and we hope to hear from you soon.
Vielen Dank.